Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 5 of lesson number 8, motion. Now as you all might be knowing, we are discussing about different types of motion, distance, speed, velocity, acceleration, how to calculate the average time taken, how to do the conversion from kilometer to meter, right? There are so many things that we studied in last part, that is part 4, right? And I hope every one of you have understood till there, because today we will be discussing on a new topic where we will be having like graph and all to discuss on, right? So this is like something which you have to observe around yourself, and then these concepts are going to be clear to you all. So I can say these are conceptual studies, like conceptual based studies, where you have to like perform the activity if possible for you, or if not, like, see, whenever you're changing the position of some object, that is also called as motion itself, right? Then acceleration, speed, velocity. Now let's say they have asked you to calculate the average speed. You have to think of that you are at the same position, then what will be the average speed of yours? Like if you're driving the vehicle, if you're driving 5 kilometer in 1 hour, what will be your average speed? How will you calculate that? So it's like you have to apply it and have some real life examples attached, so that you're understanding the concepts and you're not rectifying anything, because that is what I don't want you all to do. Okay, so try to understand the concepts. That will be like better, and like it will help you further as well. So before I proceed with today's part, that is part 5, I want each one of you to please revise whatever notes you have taken till now for the lesson motion. Okay. I hope everyone have revised whatever notes you had in your book. Now I'm going to show you the slides one by one and I want you all to please go through it again. Okay? So we started the lesson motion by discussing on like describing motion with different examples and the definition for it. So please go through it everyone. After this, describing motion along with examples, we discussed on motion along a straight line. So I want each one of you to please go through it quickly. I hope everyone is going through it. Then we discussed on this activity 8.1. So here you have to revise it as such that you know the explanation, the observation, and the inference or conclusion for the activity. Okay? I hope everyone is like explaining the observation and explanation to yourself. After this activity, we discussed on one more activity over here between the about the displacement between Bhubaneswar and New Delhi, right? after this activity 8.2, we discussed on uniform and non-uniform motion. So here with the example, we have the proper definition of what exactly uniform motion is, right? So the type of motion in which the object is going to travel with a uniform speed, that is uniform motion, and when the speed keeps on changing, okay, then that is non-uniform motion. So I want you all to please go through this slide as well. After discussing on uniform motion, we even discussed on non-uniform motion along with an example. So we can define non-uniform motion as the type of motion in which the object travels with a varied speed, means the speed is going to change continuously. Then that type of motion becomes non-uniform motion. And here we have like one more kind of motion, that is rectilinear motion, right? So over here in rectilinear motion, the motion is not going to be consistent, okay? And the acceleration of the body with respect to rectilinear motion is always going to be non-zero. After discussing on non-uniform motion, we had this activity 8.3. So over here, like, you need to know the explanation, observation, and the conclusion for the activity as well. After discussing this activity 8.3, we discussed on like how can we calculate the rate of motion, right? And over here, like the SI unit of the speed is given, and like the SI unit can be asked as objectives as well, right? So the SI unit of speed is meter per second, and the representation of the symbols are also been shown, so that should also be known to you. And the other units of speed is like centimeter per second, kilometer per hour. So like if you are using the SI unit, it should be meter per second, but other units can also be used, or you will have to convert the units. So please go through the slide as well, everyone. After this, we discussed on the formula for average speed, that is equal to like total distance traveled upon total time taken. And if you remember, we even we even have gone through some solved examples so that you can understand like how to calculate average speed, right? So just go through the slide once, and then we'll even go through the example that we had discussed. So this is the solved example like on like how we have to exactly calculate the average speed of the object using the formula total distance traveled upon total time taken, right? So I want you all to please go through it quickly. I hope every one of you are going through the solved example that has been shown on screen. After this activity, we even discussed on like speed with direction, right? So here we have the formula of calculating the average velocity. First we were discussing on calculating the average speed. Then the next thing that we discussed was calculating the average velocity, whose formula is like initial velocity plus final velocity divided by 2. And we represent average velocity as VAV, and initial velocity has been represented as U, final velocity as V. So the formula becomes VAV is equal to U plus V divided by 2, right? And always remember that speed and velocity, they both have the same unit, that is meter per second. So this can be asked as true or false as well. I hope everyone is going through this slide. After this, we discussed on this activity 8.4 as well. So please go through it as well, everyone. After this, we even discussed about lightning and thunder, right? And we even discussed on like why what has been heard first, the sound or the light, right? So over here you have to answer the question Like the sound of the thunder takes some time to reach you after you see the lightning. It means lightning is seen first and then the sound comes. So we have already discussed the reason for this, right? And here, over here, they have given us the value, like uh, what is the speed of sound in air, and that is 346 meter per second. And then we divided like in an hour, for we got the answer as 12, and then we have calculated it further, right? After this, we even discussed on how can we calculate the average speed of the car in kilometer per hour and meter per second as well, right? So please go through the solved example as well. After this, we even discussed on this example 8.3, where we calculated the average speed and the average velocity over here using the given formula, right? After this, now we will be discussing on the rate of change of velocity, like how exactly velocity changes, right? And at what rate. So now you know what is uniform motion. Whenever like any object is moving with a constant speed, that is what we know as uniform motion, right? So during the uniform motion of a body in a straight line, the velocity remains constant with time. Why it is remaining constant with time? Because it's a uniform motion, right? And during this uniform motion, the body is in straight line. So in this case, the change in velocity at any time interval is going to be zero, because the velocity is not changing over here, right? And when it comes to non-uniform motion, the velocity will change with time. Now uniform motion itself, it means that the time remains constant, and that is why the velocity remains constant. But non-uniform motion, the you can say in non-uniform motion, the motion keeps on changing with time, right? And that is the reason that velocity is also like going to change with time. Okay, so in this case, the change in velocity at any time interval is not zero. So for uniform motion of the body which is traveling in a straight line, the velocity will be zero. But for non-uniform motion, it is going to change with time, and that is why it is not going to be zero. It may be positive or negative, but it will not be zero. Okay, so the quantity which specifies the change in velocity is acceleration. Now if you have been asked to define acceleration, it is the quantity which specifies, like change in velocity is acceleration itself. Okay, so you can see the figure that has been given. Distance from home is x. Okay, there's a stoplight and a work, and delta x upon delta t is been shown. So uniform motion of a body means the body is traveling at a constant speed. Okay, and non-uniform motion means the speed is changing, right? So that can be seen with the graph itself that has been shown on screen. So how can we define acceleration? It is the change in velocity of a body per unit time. So that is how like you get the formula of acceleration as change in velocity divided by the time taken. Now we represent acceleration with a small a. So A is equal to, change in velocity will be V minus U. That is initial velocity minus final velocity upon time taken will be T. So the formula for acceleration becomes A is equal to V minus U upon T. Okay. So before we proceed further with the activity, I want you all to please write what exactly happens in uniform motion, why the velocity is zero, and for non-uniform motion, why the velocity is non-zero. And even we will be writing about the definition of acceleration and the formula which is used to calculate acceleration, that is V minus U upon T. So I want you all to write about acceleration as well in your book. I hope every one of you are writing it. After this, now we have an activity 8.6 to discuss. So see, in your everyday life, you come across a range of motions in which acceleration is in the direction of motion, acceleration is against the direction of motion, acceleration is uniform, acceleration is non-uniform. So, can you identify one example each for the above type of motion? Now, I want you all to tell me this, like, think of it and try to answer the questions which have been given. I hope every one of you are like trying to answer and coming up with an example. Once you come up with it, I'll tell you what exactly you can write over here. Okay. So I'll tell you an example for acceleration when like acceleration is in direction of motion. For that, you know that acceleration is a vector quantity, right? So because it is a vector quantity, it is going to show the velocity, it is going to show that velocity is changing either in magnitude or is changing its direction as in circular motion, or it can change in both the way, that is in magnitude as well as in circular motion. Okay, so when magnitude is increasing with time, the acceleration will be in direction of motion. Okay, what I said, when velocity will increase with time, the acceleration will be in direction of the motion. For example, like a just started vehicle, like an airplane taking off on the highway, that is an example of acceleration in the direction of motion. Okay, then second one is acceleration is against or opposite to that of motion, then in that case its reverse is also true, right? When velocity decrease, in the first one velocity was increasing with time, but over here when acceleration is against the direction, in this case velocity will decrease with time, and over here the acceleration is in the opposite direction of the motion. An example, you can write a stopping vehicle, because the acceleration is against the direction of motion, the vehicle stops. So starting of the vehicle is acceleration is in the direction, and again when the acceleration is against it, it will be stopping the vehicle. Then uniform acceleration, you can give a real life example over here is free falling ball. Okay, now you know that the earth attracts every particle with its gravitational pull, right? So this gravitational pull is going to create an acceleration which is going to be constant, that is 9.8 meter per second square. Okay, then acceleration is non-uniform. So non-uniform acceleration is not so common in real life. Only few things have non-uniform acceleration, like one is object moving in circular motion with a uniform speed. So here the speed will remain the same, but the velocity and the acceleration will keep on changing its direction, and you can say direction with time. So here the acceleration becomes non-uniform. You can write movement of ceiling fan, a spinning tube. These are examples of non-uniform acceleration. So I just want you all to write all the examples in your book, but please be quick with it, everyone. I hope every one of you are writing the example. I hope every one of you are writing it. because after this we have one more thing to discuss, and after that we're like, I'll stop for the day. After this, here we have an example 8.4. See, starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brake such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. So, calculate the acceleration of the bicycle in both the cases. So, how will you do that? So see, in the first case, initial velocity, that is u, will be 0. Final velocity v will be equal to 6 meters per second, and the time taken will be 30 seconds, right? So from the equation we have like the formula as a is equal to v minus u upon t, right? And you know v is 6 meter per second, u initial velocity is 0, and t is 30 seconds. So you get the answer as 0.2 meter per second, right? Then in the second case, the initial velocity is 6 meter per second, final velocity is 4 meter per second, and time taken is 5 seconds. So according to that, you get the uh, acceleration for second case as 0.4 meter per second. So the acceleration of the bicycle in the first case is 0.2 meter per second, and in the second case is 0.4 meter per second. Okay. I hope you all are going through it. After this, in the next class, I'm going to start with graphical representation of motion. Okay, so along with that, like under this graphical representation of motion, we are going to discuss on the distance time graph in detail. Okay, after the distance time graph, we will be discussing on velocity time graph. Okay, then after velocity time graph, we will be discussing on, see, there are so many things to discuss along with activity, right? There are so many activities as well. Okay, equation of motion by graphical method. Okay, then we will be discussing on equation of motion by graphical method. After that, we'll discuss on equation for velocity time graph. Then after this, we will be discussing on equation for position time relation as well. Okay, and after equation for position time relation, we will be discussing on equation for position velocity relation. This is also again very important, and over here we have like the example as well to discuss, so we'll be doing that as well. We have example 8.6, 8.7, and then we have uniform circular motion to discuss in detail along with the formula, along with the activity, and then the summary discussion for the whole lesson. Motion, we'll be doing this, and after that we'll have discussion on the exercise question. So I want each one of you to please go through it quickly. I hope every one of you are going through the question. So this is how we will be ending up with the lesson motion, and I hope whatever we have discussed so far in the lesson, every one of you are very much clear with each and every concept which has been taught. And as you have seen, there are so many examples to discuss on. We have even discussed each of them, right? So make sure you all are revising it thoroughly, and you know how to calculate them along with the proper proper application of the formula. Okay. So now whatever part has been left for the lesson, I'm going to continue that in the next part. Thank you everyone.